All right, 8th graders, lesson 74, simplifying square roots. We need you to really focus in on this one here today. This is a lot of new stuff for us. We've used the Pythagorean Theorem here. Draw a couple squares. And we've learned that if we look at the triangle here in the middle, this is a 45, 45, 90. Therefore, we know that the side lengths here, this is 1, this will be 1, and this will be the square root of 2. So we know that if we made this little square here, we know the diagonal of a square then is going to be the square root of 2. So if I have 4 squares and I have 2 diagonals there with that line will be 2 times the square root of 2, which is the square root of 8. And if I make a little bit bigger one here with 3, I've got a line going through there. Now I've got 3 square roots of 2. 1, 2, 3, and that's really the square root of 18. So we're going to be working on these different square roots and working on simplifying them. Before we do that, we can simplify roots by combining them. If you would give me the square root of 2 times the square root of 6, I could say, well, that's a square root of 12. We can multiply the numbers that are inside. Just as if you gave me the square root of 12 and said simplify that, I could say, well, it's a square root of 4 times the square root of 3, because 3 and 4 equal 12. So I can simplify things. So the basic rule here is if you have a times a b in a square root, you can also separate them into the 2 separate square roots, and that will be understood that the symbol here is between them is multiplication. So again, we'll start here with simplifying square root of 12. We could say, well, square root of 4 times the square root of 3. I could also do square root of 6 times the square root of 2. But in this way, then you can say, oh, hang on, this can become a 2, and this will remain the square root of 3. So 2 times the square root of 3 equals the square root of 12. The square root, to do another one, the square root of 8. You can say, well, that's a square root of 4 and the square root of 2. And this I can simplify into 2, but the square root of 2 I cannot. So the square root of 8 equals 2 times the square root of 2. If we do another one, square root of 18. Again, I can do a bunch of things here, but I'm going to do the square root of 9 times square root of 2, because 9 times 2 is 18. I can make that a 3, and this will have to stay the square root of 2. So the square root of 18 equals 3 times the square root of 2. We saw that with our squares on the time before. So we're factoring them. We're dividing these up and trying to get them some different ways. If we go back to this one over here, square root of 12, you might say, well, what if I did the square root of 6 times the square root of 2? I'd say that's fine, because 6 could be split into the square root of 3 times the square root of 2 times the square root of 2, and that would further be simplified into these two would combine to make a 2 times the square root of 3, and you see that's the same answer that we got up here. So lots of ways of solving these. Square roots will help us find some different things, like square root of 600. You see here, so we write the factors of it. What are all the prime factors? Well, if I do a factor tree, I get a 2, and a 2, and a 2, and a 3, and a 5, and a 5. Now I can group them. Let's see, square root of 2 times 2, and the square root of 5 times 5, square root of 2 times 3. So this will become a 5. This will become a 2, because 2 times 2 is 4, so the square root of 4 is 2. 5 times 5 is 25, so the square root of 25 is 5. So that's how I'm getting these here. And then over here we're left with the square root of 2 times 3 And now we can multiply these two here. That'll be 10. And 2 times 3 is 6. So by using factoring, we learned that another way of writing the square root of 600 is 10 times the square root of 6. Later on, if we get a square root of, say, 400, we can say, oh, that will be 10 times the square root of 4, which would be 2. 10 times 2 is 200. So there are ways that we can simplify this. Example 1, square root of 216. They need to simplify. So I'll make a factor tree here. 2 times 108. Let's see, 2 times 54. 2 times 27. 3 and 9. And that'll be 3 and 3. So the square root of 216, I can say, is 2 times 2 times 2 times 3 times 3 times 3. And now if I group them, 2 and 2, 3 and 3, and 2 and 3. So I've used each one of them, 2 and 2, 3 and 3, and then 2 and 3. This will be a 4. No, sorry. That will not be a 4. That will be a 2. Because 2 times 2 is 4, and the square root of 4 is 2. This will be a 3. So 2 times 3 times the square root of 2 times 3. This will be 6, and this will be 6. So that's my answer here, simplified, 216. First we do a factor tree like this. We take all the square factors, put them under here, try to group them as best we can so that we get these ones that will give us a number that is not in the square root box. We can combine those until finally we get down to here. All right, for B, we've got 210. So again, that'll be 2 and 105. There's a better way. Why don't we do 21 times 10? Let's see, that'll be 3 and 7, and that'll be 2 and 5. So not a lot of them there. So 2, 3, notice always put these in order from least to greatest. And because it's got no identical factors, I can't simplify it any further. So what I can go back now and say is 210 is as simplified as I can get. It cannot be further simplified. Example 2, we see instead of walking 200 yards from point A to point B this way, because from A to the corner here is 100 yards, and from B to the corner 100 yards. So I'm saying, hey, let's take a shortcut right here. And so how long would that shortcut be? Well, using the Pythagorean Theorem, and we see this is a 90, 45, 45. So we know the distances of the sides, 100 squared and 100 squared. So 100 squared plus 100 squared, that's going to be, let's see, 10,000 and 10,000. So 20,000 equals c squared. So if I want to get c all by itself, I find the square root of 20,000. That cancels that out. Now I can simplify square root of 20,000. That's going to be square root of 100 times the square root of 100 times the square root of 2. And if I combine these two right here, they will equal 100 times the square root of 2. So the actual distance over here between A and B is 100 times the square root of 2 yards. Now you might say, well, that's nice mathematically. Approximately how much is that? Well, we remember the square root of 2 is approximately 1.41. So we move the decimal so we can say it's approximately 141 yards. So instead of walking 200, he could walk only 141 yards. And using this picture, we see here are, so as you can see here, you've got the square root of 2 is approximately 141, square root of 3 is approximately 173. These are not things you need to memorize necessarily. It's helpful to memorize them. You can do your math work a little bit quicker, but obviously you have your calculators with you to find these square roots out, because a lot of times, like they did in example 2, you can then figure out the approximate value of them. So a lot of new stuff today with these factors. Don't be afraid to rewatch the lesson if you need to on YouTube. Just if you get more questions or be afraid to ask, you can get started on your practice set today.